Hi, this is Somshakar from Maths Guru Academy. If you are watching the video for the first time, please subscribe to my channel and press the bell icon to get the notifications of my latest videos. So next question, example 5, prove that root 3 is irrational. If you know how to prove that root 2 is irrational, so as it is in the same way we can solve root 3 is irrational. So first we will consider root 3 is rational, then we will prove root 3 is irrational. So proof. So let us assume root 3 is rational. So let us assume on the contrary that root 3 is rational. So if root 3 is irrational, then this root 3 can be written in the form of a by b, right? So we have one condition that a and b are co-primes. Co-prime means both a and b should have common factor 1. That means HCF should be 1. And one more condition that b must not be equal to 0, right? So since we consider root 3 is rational, this denominator must not be equal to 0. That is one more condition. So next we'll shift to b to the LHS. What it will become? Root 3 into b is equal to a. In the next step we will do squaring on both sides. So next root 3 into b whole square is equal to a square. So root 3b whole square means this square is for both root 3 and b. What it will become? Root 3 into b whole square means this square is for both root 3 and as well as b. So here square and square root cancelled. So 3 as it is into b square as it is. So finally root 3b whole square can be written as 3b square. 3b square is equal to a square. So from this equation 3b square is equal to a square, we came to know that 3 is one of the factor of a square, right? So 3 is one of the factor of a square. That means 3 divides a square. That implies 3 also divides a, right? So let it be equation 1. So this one from theorem 1 point, this one from theorem 1.2. So next, if 3 divides a, we will get some integer, right? So if we multiply that integer with 3, then we will get a. For example, let us consider this a as 12. So if we divide that 12 by 3, then we will get 4. Right? That means if we multiply this 4 with 3, we will get 12. Right? So likewise, if we multiply this 3 with some integer, we will get a. Getting the point? If 3 divides a square, we will get some integer. If we multiply that integer with 3, again we will get the value of k. Right? So this is the equation 2. Substitute equation 2 in equation 1. So equation 1 3b square as it is. So in place of a we will substitute 3k. So this square as it is. So 3b square as it is. 3k whole square means this square is for both 3 and k. So the value of 3 square is 9 and k square as it is. In the next step we will shift 3 to the RHS. So what it will become? B square is equal to 9k square by 3. 3 ones are 3 3s are. So finally B square is equal to 3k square. From this equation B square is equal to 3k square, we came to know that 3 is one of the factor of B square, right? So therefore this 3 divides B square as well as 3 divides B. Right? So this is from theorem 1.2. So let it be equation 3. From equation 1 and 3, we came to know that 3 is a common factor for both a and b, right? 3 divides a and b. That implies A and B have common factor 3 which is contradiction to our assumption that A and B are co-primes, right? So what is our assumption? A and B must be co-primes. Co-prime means common factor must be 1. But here from equation 1 and 3 we came to know that both A and B have common factor 3. So which is wrong to our statement, assumption, right? So therefore root 3 is irrational.